Alright, here's the next piece of the final exam review. This is covering page 7 of your main final exam review packet, which is problems 56, 57, and 58. All three of these problems have the same directions as the last problem in the last video, which is to solve the following triangle. Assume that A is opposite angle A, B is opposite angle B, C is opposite angle C in triangle ABC. Show all work. So, again, we need to start off by drawing a picture. We're going to draw a generic triangle. Doesn't matter if it's accurate or not, as we're just going to apply our rules for triangles either way. Now, this particular problem gave us all three side lengths. Little a is 965 inches, little b is 876 inches, and little c is 1,240 inches. That should say inches, so that's a typo. We need to fix that. It can't be feet. If it's feet, this triangle would definitely not exist. Okay? So that should be inches as well. So first mistake I found in this entire packet typo-wise, please make sure that you change that on your packet and try this problem again if you had issues. So anytime that we are given side, 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 that is a law of cosines problem, which means the examples in your notes are in section 7-3. Now, if we are being asked to solve this triangle, we need to provide three answers: the measure of angle A, the measure of angle B, and the measure of angle C. So in a side, side, side situation, we do have to start by finding a very specific item, and that is the length of the largest angle. Now remember that geometry tells us that the shortest side of the triangle is always opposite the smallest angle. So angle B would be the smallest angle because 876 is the smallest side length. And the largest side length is always opposite the largest angle. So the first step that we have to do here, and we have to do this first, so we'll call this step 1, is we have to find the measure of angle C first. We have to find the largest angle. And to do that, we are going to use the version of the law of cosines that contains the measure of angle C, which would be little c squared equals little a squared plus little b squared minus 2 little a little b cosine of angle C. We plug in what we know, that is 1,240 squared equals 965 squared plus 876 squared minus 2 times 965 times 876 cosine of angle C. Now it's worth noting that we cannot put all of this into the calculator at one time. There are essentially three pieces that we can evaluate on the calculator right now. We can do 1,240 squared, which is a fairly large number. It is 15,000, or 15,376,000. And we can do 965 squared plus 876 squared. We can do all of this at one time. So we put that in the calculator. That is also a fairly large number. That would be 1,698,601. And the final piece that we can do at this time is negative 2 times 965 times 876, which is negative 1,690,680 times the cosine of angle C. Anytime. There we go. Now, essentially what we have here is a two-step equation. We're going to have to subtract this purple number, divide by this red number, and then take the inverse cosine to get C by itself. So our first step here is to subtract 1,698,601 from each side. Be very careful typing that into the calculator. Cancel there. So we have I must have too many zeros on that number. Let me check that number real quick. 1240 squared. Yeah, there should only be 2 zeros on that number. So that shouldn't be, that should be right there. There we go. And we're subtracting that. There we go. That's all better. I just put too many zeros on it when I typed it in the calculator. That would be negative 161,001 equals negative what's left on the right side, which is 1,690,680. So then we divide each side by that number. So we divide by negative 1690680. And that gives us a, I'm sure to be very ugly decimal. So negative 1690680. That is 0.095228547, which equals the cosine of angle C. And that tells us that C is the inverse cosine of that decimal. So feed that to the calculator. And we're going to round to 3 significant figures because that's what the problem calls for. We get 84.5 degrees for the measure of angle C. So the measure of angle C is 84.5 degrees. We'll go ahead and write that on the picture as well, 84.5 degrees. Okay, so now that we've done the law of cosines one time, we do not ever need to do the law of cosines again. You only ever have to do it one time. So we did the law of cosines, we found the measure of angle C. Now what we do is we use the measure of angle C to find one of the others. And it doesn't matter which one, so let's find the measure of angle A. And we're going to do that by doing A over sine A equals C over sine of angle C. We're going to use the law of sines. So we say 965 is to the sine of angle A as 1,240 is to the sine of 84.5 degrees. Now we did these on the example in the last problem. That's a proportion, so we're going to cross multiply, which gives us 1,240 times the sine of A equals 965 times the sine of 84.5. Then we're going to divide each side by 1,240. The difference is that we've never had to deal with this equaling the sine of A before. So the sine of A is that fraction, 965 times the sine of 84.5 divided by 1,240. That means that A is the inverse sine of that fraction, 965 sine 84.5 divided by 1,240. So we feed this to the calculator, second sine, fraction button, and start feeding it in. 965 sine 84.5 divided by 1,240. And we get, again, we're going to round to 3 significant figures, that angle A is 50.8 degrees. So there's our second answer. Angle A is 50.8 degrees. 50.8 degrees. Now that's a vast majority of the work, because from there, now that we've gotten the first 2 items, now we only need to find the third angle. Well, Finding the measure of the third angle, which I guess I should write step 3 so that our work is nice and organized here when we get done. If my computer ever gets there. Come on, guy. Alright. So step 3, we're going to find the measure of angle B. Remember that the measure of angle B will be 180 minus the two angles that we know. So minus 84.5 and minus 50.8. So that means that the measure of angle B is, just feed it to the calculator, 44.7 degrees. 44.7 degrees. And there you have it. That is a solved triangle. So I'll pause here for a minute in case you want to pause the video and absorb that work a little bit. And then I'll move on to the next problem. Okay, next problem. Here we have another triangle. Again, we know it's an ABC, so we just draw a generic triangle. Doesn't need to be perfect. It's not important. Angle B is 72.2 degrees. Little b is 78.3 meters. And little c is 145 meters. So we need to find little a, the measure of angle A, and the measure of angle C. So we'll make a little box up here and we'll write that down. We need to find little a, the measure of angle A, and the measure of angle C. Now this is a law of sines problem, which means it's either section 7-1 or 7-2. It really just depends on what you're given as to what approach you take, because this might be an ambiguous case problem. So we need to look here. Okay, we are given two sides and an angle. So we are given SSA. Okay, we're given two sides and an angle that's not included. That is the ambiguous case. So specifically, you should be looking at section 7-2 in your notes. This is your ambiguous case, which means you're looking at your notes for section 7-2. Okay? So, we start off finding the only thing that we have enough information to find. The only thing that we have enough information to find is the measure of angle C. So step 1, we use the law of sines to find the measure of angle C. That is, we say little b over the sine of angle B equals little c over the sine of angle C. Now, we plug in what we know, 78.3 divided by the sine of 72.2 equals 145 divided by the sine of angle C. We do what we always do. We cross multiply because it's law of sines, which will give us 78.3 times the sine of angle C equals 145 times the sine of 72.2. We divide by the sine of 78.3 to get sine C by itself. And that gives us that sine of C is equal to that fraction, 145 sine 72.2 divided by 78.3, which means that angle C is the inverse sine of that fraction, 145 sine 72.2 divided by 78.3. And we feed that to the calculator. We're going to round our answer to 3 significant figures. So we feed that to the calculator, we hit second sine, and then the fraction button, and then type in that fraction, 145 sine 72.2, close, over 78.3, and we get a domain error. Okay? Now if that happens, if you get a domain error, what does that mean? That means no such triangle exists. Remember that with the ambiguous case, there could be 0, 1, or 2 triangles. So if you go through all this law of sines work, okay, all this law of sines work, which by the way, if you go back and type that fraction in without the inverse sign, you get a value of, this right here, is 1.763202579. Right there, we would have known that this triangle doesn't exist because sine, the domain of the sine function, only exists between -1 and 1. This value is not between -1 and 1. So that means that there is no such triangle, and we are done with this problem. We say no such triangle exists, and we go to the next problem. I'll pause that so you can take a minute and look at the work. And on we go. The last problem on this page is yet another law of sines, law of cosines problem. So as soon as the computer decides to change the page, there we go. We will once again draw a picture of triangle ABC. Angle C is 29 degrees 50 minutes. Little c is 5.21 meters. And little a is 8.61. Wow, I did it again. That should also be the same unit, so we're going to change that to meters. Seems like somebody in class should have noticed this and yelled at me by now. Well, I guess we're going to change that too. That should also be in the same units. There's no reason for them to not be in the same units. So if anybody watches this tonight, haha, you need to ask me about all these typos tomorrow, okay? If you do that, if you come in tomorrow and you say, Mr. Wills, your video said you had a whole bunch of unit typos, I will reward you. So let's see if anybody's actually using these or not. Alright, so the only information that we can find, we need to find three things again, like always. We need to find the measure of angle A, we need to find the measure of angle B, and we need to find the length of the side opposite angle B, which is little b. So the only thing that we can find, this is step 1, is the measure of angle A. That's the only thing that we have enough information to find. We're going to do A over sine A equals little c over sine C. So that would be 8.61 divided by the sine of angle A equals 5.21 divided by the sine of 29 degrees 50 minutes. Now if you don't remember how to type 29 degrees 50 minutes into your calculator, you probably need to come see me after school tomorrow, because that's going to be on your final and you need to know how to do it without asking me. Cross multiply would give you 5.21 sine A equals 8.61 times the sine of 29 degrees 50 minutes. We divide by 5.21. So I'm going to go ahead now and feed that fraction to the actual calculator right now. So 8.61 times the sine of 29 degrees (50 minutes) divided by 5.21. And this one will exist because that is 0.822128944, which means that A is the inverse sine of that fraction. So we take the inverse sine on our calculator, and we get that angle A is, and again, three significant figures, 55.3 degrees. Could write that in degrees and minutes, but we don't need to. So 55 degrees, 55.3 degrees, I should say. Come on, calculator. There we go. 55.3 degrees. So 55.3 degrees is the measure of angle A. Which means we can find now the measure of angle B. So step 2, we're going to find the measure of angle B. And that's because we now know that angle B is 180 degrees minus the other two angles, 55.3 and 29 degrees 50 minutes. It doesn't matter that these aren't both decimals. You can type that in the calculator. So 180 minus 55.3 minus 29 degrees and 50 minutes. So the measure of angle B is 94.9 degrees. So 94.9 degrees. 94.9 degrees. Okay, that just leaves the measure of angle, or the length of side B. So step 3, we're going to find the length of side B, which we're going to do B over sine B, equals, and we're going to use C over sine C because those were the values given in the problem. That way if we screwed something else up, it won't screw up this number. So that would be little b over the sine of 94.9 degrees equals little c, 5.21, over the sine of 29 degrees 50 minutes. Cross multiply gives us b times the sine of 29 degrees 50 minutes equals 5.21 times the sine of 94.9 degrees. We just need to divide each side by the sine of 29 degrees 50 minutes and feed it to the calculator. So b, rounded to 3 significant figures, would be, type this in the calculator real quick, 10.4 meters. Now, we're pretty much done, but here's the thing. The answers we found are the answers to a triangle with these measurements. The problem is that with the ambiguous case, which this is again, we were given side-side angle, which means that this was ambiguous case. So if we find a triangle, then we have to do what's called the second triangle check. Okay? Do the second triangle check. The first angle we found was angle A. Angle A was 55.3 degrees. That is now going to be called A1. This is because there might be an A2. A2 would be 180 minus 55.3, the supplement, which would be 124.7 degrees. So if there is a second triangle, then that second triangle would have an A value of 124.7 degrees. So the way that we check is we add A2 to the other angle we know, angle C, 124.7 degrees, plus 29 degrees 50 minutes, and we figure out what that value is. So 124.7 plus 29 degrees and 50 minutes. Well, that's bad news for us because we got a number that is less than 180. Since that number, 154.53 repeating, is less than 180 degrees, there is a second triangle that we need to find. So we're only halfway done with this problem. Actually, we're more than halfway done. That second triangle, we actually already know 4 pieces of information about. Okay? So we're going to make a copy of this slide. Let's see here. I need to open up the side menu here to finish this problem. So I need my computer to catch up with me. Come on, computer. You can do it. Okay, there we go. All right, so we're going to take the slide we're on and we're going to copy it. And then we're going to paste it right in place. Maybe. There we go. We're just going to paste it right in there. Now there'll be 2 copies of it, so we're waiting for 22 to turn into 23 in the upper right-hand corner. Come on. Come on. You can do it. I have faith in you. I love it when it adds time to my videos because it doesn't want to react in a timely fashion. So again, what we're doing here is we're going to be creating a second triangle with the same starting measurements, so 29 degrees 50 minutes for angle C, and little a will be 8.61, and C will still be 5.21 degrees. So essentially what I'm doing here is I'm creating a second set of answers, okay? That's why I duplicated the slide, with an entirely different set of work. So I'm going to clear out all the work we did for the first triangle, which is still earlier in the video and also on the earlier slide. And we're going to redo this work with the information for the second triangle. Okay? So here's what we know. The 94.9 is no longer the angle B, and 55.3 is no longer angle C. Instead, we already found out, I'm going to fix this up a little bit here, okay, that we already know the measure of angle A2. Okay, we're going to have a new B2 and a new B. So those first set of answers here that we already have on the previous slide, and now we're waiting for it to do that. These are now the answers to the first question. So we would then relabel those A1, B1, and little b1. Okay? So these are now we're finding the second triangle's answers. And we already found that the measure of A2 is 124.7 degrees. So in a way, we're a little bit further along than we were. This angle is 124.7 degrees. And I know what you're thinking, it doesn't look like an obtuse angle. Well, again, you don't trust your picture, you trust the numbers. So from there, we only have 2 steps to do, okay? So the next step for the second triangle, I guess, let's see, this would technically be, because the second triangle step would be step 4 in the process. So this would be step 5. We are finding the measure of angle B2, which would be 180 minus 124.7, which is A2, and 29 degrees 50 minutes, which is still the measure we were given for angle C. So that we just have to feed to the calculator, 124.7 and 29 degrees 50 minutes. That would be 25.5 degrees, because again we're going to round to 3 significant figures, so 25.5 degrees. So this angle up here would be 25.5 degrees in our second answer. That just leaves little b, which I should have erased a little while ago. We don't know what that is yet, so it shouldn't say 10.4. That was the answer to the first question. And now we're going to do the final step, step 6, which is to do the law of sines one more time to find the second answer for little b. So we're saying little b2 over the sine of big B2 equals little c over the sine of angle C. So that would be, we don't know what that is, little b2, but we do know that angle B2 is 25.5 degrees. We know that little c is 5.21, and we know that angle C is 29 degrees 50 minutes. So again, we're just setting up the law of sines and doing it again. We're going to cross multiply, which will give us, and I'm going to move all the way back over here, little b times the sine of 29 degrees 50 minutes is 5.21 times the sine of 25.5. The only thing we need to do to put that in the calculator is divide by the sine of 29 degrees 50 minutes and then feed the calculator. we're going to put this in the calculator because that cancels. And that gives us our final piece of the puzzle, which is little b2. Again, we're going to round that off once we put it in a calculator. So 5.21 times the sine of 25.5 divided by the sine of 29 degrees, 50 minutes, which would be 4.51 meters. So if this happens on the final, you would have to provide the answers to both triangles to receive full credit on the problem. That's the joy of the ambiguous case when we are given two sides and a non-included angle. So again, we have two separate answers. Our first set of answers we are calling A1, B1, and angle B1, angle A1, and little b1. Okay, those numbers are shown here on the graphic. They're also over there in the box. We then ran the second triangle check and discovered that there was a second triangle. So then we started the problem somewhat over with the new A1 value, which is now A2, and found B2 and little b2 using a similar approach that we did in the first problem. Okay, so that takes care of that page of the final exam review packet. It's probably the hardest one in it.